Hello, hi to everyone. Next we are moving to the next topic, phase of NAC as well as phase difference. Then we'll discuss the problems, three problems in this particular video. Okay, so let us start the concept here, the phase of NAC. Okay, so the phase is nothing but a reference, or for example, you are starting from zero, that is called as a phase for that particular waveform. So let me take the waveform here. Okay, so it will be theta or time or omega t. Maybe you can take any reference, no issue. So for example, this is a current waveform. For example, that is a current waveform. So it is 0, it is pi by 2, so it is pi, it is 3 pi by 2, and it is 2 pi. Okay, now in this particular case the phase is nothing but the reference point. The phase is nothing but a reference point or starting point of the waveform. Okay, starting point of the waveform. So here the phase is starting from where? 0. So 0 degrees, it is a phase angle. The phase is starting from 0. That is a reference for this particular waveform. Okay, clear? So in that case, in the it is measured in we'll discuss the 3 points here. The first point, time measured in seconds. In this case, the phases time in terms of time measured in seconds. For example, here if you are considered time, it is measured in seconds. For example, you can fraction of time. For example, you take the fraction of time. What is the waveform? What is the phase angle? Can also find out. Third one, it is also expressed in radians. Okay, here radians omega t. You can also express in angle. So for example, 5 by 6 is a phase angle they given. In terms of degrees, it is a 30 degrees. Okay, the phase angle. So for example, 1 by 12th of the cycle of a fraction of t by 12. So this is a terminology related to the phase angle. So don't confuse about the phase angle. Just once again I will tell you, the phase is nothing but a reference point or starting point of the waveform. So for example, you start from 0, the phase, for example, your reference also 0 degrees is a phase angle. For example, it is starting the waveform is 30 degrees. We are taking the reference point is 0. What is the phase angle? 30 degrees. Okay, let us discuss in the one by one. So this is the phase. Now we are moving to discuss about the phase difference. Phase, then you will get the idea. Phase difference. Okay, so I will take two waveforms, then I will explain the phase, what exactly the phase difference, what is the leading, what is the lagging, how to write the equations. Let us see. So now I'm consider, okay, it is a time period. So for example, in India, what about the frequency? 50 Hz is a frequency. Now it is a 1 half cycle, second half cycle. This is the one of the waveform. Now I will take another waveform. It is starting from 60 degrees. Let me take. It is 0, but another waveform is starting. It is. So see here, everyone look at here. So in this particular case, we have two waveforms. The first waveform is A, second waveform is B. So that means this particular waveform is started, second B waveform is started after 60 degrees, right? That means what is the phase angle of B? 60 degrees. What is the phase difference of A to B? 60 degrees, right? The phase difference. So now this is a 60 degrees. Now this is a 60 degrees is the phase difference. Similarly, the wave the waveform of A is lagging with B, because the waveform is leading, because it's starting from 0. After 60 degrees the waveform B is started. So here current I, let me take another color. Here current I, A for example, is leading, IA is leading, shit. Okay, here IA is leading. When reference to, we are taking the reference to B, IA is leading by 60 degrees with B, IB. All of you got my point. So you can say that IA is a leading current. Next, another way you can represent it, IB is lagging, IB is lagging by 60 degrees with reference to IA. That is also correct. Finally, all of you got it. So what is a lagging and leading? Based on the reference you are taking, we can call it as a lagging or leading. Okay, these two waveforms I compare. So IA is a leading one with reference to IB. IB is a lagging one with reference to IA. So that is about the lagging and leading concept. Then I will take different waveforms. Then I will show you how to write the IA, IB values. In this case, we can write IA is equal to IM, that is a maximum value of current, that is IM, into sine omega t plus 0 degrees. It is starting from 0, right? This is the first equation. Next, IB equation. IB is equal to IM into sine omega. It is lagging, right? Minus 60 degrees. It's starting after 60. So those are the representations of this particular waveform. All of you got my point. How to write the equations for both? Because this particular chapter is a basic chapter to understand the all third and fourth unit transistors, as well as AC circuit. Further AC circuits we have second, third, fourth units chapters. So everyone clearly listen. Okay. Now you know how to write IA and IB equations. Then I will draw the one more diagram for you. Can identify what is the phase angle. So here time period t, current I for example. So one of the waveform is started from here. For example, this is a A. Next, another waveform is also started. It is also started. This is a B. What is the phase angle? The phase angle is 0. The phase difference is 0 because both are in phase. Clear? Next, for example, I will take another waveform, can identify the phase angle. This is the current I. So one of the waveform is another waveform. So this is a, this is a B. So in that particular case, the waveform is started from here. Another waveform is started out of phase. That means after out of phase up, it is starting from 0, it is out of phase, that is it is starting from here, it is 0 is starting from here. That means what is the phase angle? 180 degrees. That is called as a out of phase. So how to write these particular equations here? IB is equal to IM sine omega t minus phi. How to write? Whenever omega t minus phi, this waveform starting here, but this particular waveform started here, because it is 0 is starting from here. What is the phase angle now? The phase angle is 180 degrees. Okay, clear? So IB is equal to IM sine omega t minus phi, 180 degrees. What about IA here? IA is equal to same as usual, IM sine omega t plus 0. Okay, this is the way to write all the equations. Okay, so that is about the discussion about the particular phase difference concept. So conclusion here, for example, it is a leading plus sign we are using. So whenever lagging, we are indicated negative sign. Okay, so this will be explained in detail once we are going through the problems. Okay, this is about phase difference. Okay, phase and phase difference. So the first question here, a sinusoidal alternating current having a frequency of, so f is equal to 50 Hz and peak value 10 amperes. What is the value of current after 1/30 seconds from the 0? So got my point. Just now we discussed everything about the phase angle as well as phase difference. From that we are going to solve these particular problems. So this type of problems may be in the examination. So your given frequency is equal to 50 Hz. Okay. Peak value is nothing but a maximum value is equal to 10 amperes. So whenever maximum value is equal to 10 amperes, at t time 1/300 seconds from 0, okay, what is the value of current? You need to find out the current value. That is a problem. The current formula for sine wave, it is a sine wave, right? Im sine omega t. Whenever it is a Im sine omega t, what is Im value? Im value is equal to 10, right? Sine omega is equal to 2 pi, okay? Omega is equal to 2 pi f, and here t is there, t. So from that 10 into sine 2 pi f is a frequency is a 50, time is equal to 1/300. Once you done everything, 2 pi is nothing but a 360. Yes or no? You can replace by 360. So finally we'll get the value here 10 into sine 60 degrees. Whenever it is sine 60, that will be 0.866. It will be equivalent to 8.66 amperes. What is the current at 1/300 second? 8.66 amperes. Okay. Next we are moving to the second problem. A sinusoidal AC has a frequency of 50 Hz and a peak value of 10 amperes. So that means here frequency is equal to 50 Hz. Okay. Peak value, that is a maximum value, is given 10 amperes. It is starting from 0. How long will it take reach to 5 amperes for the first time? So that means I value is equal to 5 amperes. So at what time we need to calculate? Okay, this is a problem. So by from the basics, I is equal to Im, it is starting from 0, right? Im sine omega t plus 0, okay, Im sine omega t. So omega I is equal to 5 amperes is given. Im is equal to 10 amperes. Sine omega is equal to 2 pi f t, right? 10 into sine 2 pi of t is a 360 into frequency is equal to 50 and time t. From that, sine 360 into 50 t is equal to 1 by 2. Sine inverse 1 by 2, that will be equivalent to 18,000. T is equal to sine inverse 1 by 2. Sine inverse 1 by 2, 30 degrees. From that, 30 divided by 18,000, that will be equivalent to 1 by 600 second. What is the time taken to reach the 5 amperes? 1 by 600 second. For your explanation purpose, I explained each and every step. In the examination, you can do directly. Okay. Okay. In the third problem, okay, alternating current is represented by I is equal to 141.4 sine 628 t. Calculate the first one, the frequency, second one, RMS value, third one, average value. These are the things you need to calculate. So the first one, frequency can calculate. Standard formula I is equal to Im sine omega t. Here omega is a 628, right? Whenever omega is equal to 628, omega is equal to 2 pi f is equal to 628. From that, f is equal to 628 by 2 pi. Whenever 628 by 2 pi, that value is equal to approximately 100 Hz is a frequency. Okay, first part is done. Second, in the second part, RMS value. IRMS is equal to second one. In the second one, the IRMS is equal to Im by root 2. What is Im? 141.4 divided by root 2. So that will be equivalent to approximately 100 amperes. Third one, average value. I average is equal to 0.637. These all formulas we explained in the second video. Okay, lecture number 2. So just go through that, then you can watch this. Approximately we'll get the 90 amperes. This is about all are about the problems related to the phase and phase difference and different values of RMS value, average value calculations. Okay, thank you.